Energy, momentum, forces and work. And some other stuff that's on the floor now. But how do they all fit together? First of all, work. What is work? Good, honest work. But how do we measure it? Well, work and energy are measured in joules. Work comes from force and distance. Remember how? Of course you can. That man pushing a rock image is pretty unforgettable. Well, it works like this. Here's a block. All we need to do is multiply the distance by the force. So 3 metres times 100 newtons equals 300 joules of work. When you move a force over a distance, then you have done work. Now on to energy. Kinetic energy, potential energy, elastic energy, heat energy. Energy can change. A fast-moving bike wheel will transform its kinetic energy into heat energy pretty quickly if you brake suddenly. Next, pork pies. You can use a grapefruit if you're on a diet, but there's no real reason to, as we're not going to eat it. The point is to lift an object off the floor and put it on a shelf. Why not? It takes some work to lift the pie against the force of gravity. This work gets transformed into gravitational potential energy. That's the energy that would be released if it fell. If it fell. When it swings, two forms of energy are transformed back and forth between each other. But how do you know which? When you pull the ball on a pendulum out to the side, it moves up too. It is higher up, so it has gained gravitational potential energy. Remember the pie. Same principle, but less messy. Now we let the ball go. What happens to the energy? Well, as it falls, it loses height, so loses gravitational potential energy. But it starts moving faster and faster, so it gains kinetic energy. As it swings back up higher, it gains gravitational potential energy again. But also, as it swings up, it slows down and loses kinetic energy. Over and over, the energy is transformed back and forth, gravitational potential energy to kinetic energy. Each swing will be slightly less than the previous one, as some energy is transferred to the surroundings, mostly as heat, but not much heat. Kinetic energy isn't just for pendulums. Anything moving has kinetic energy. It's all about mass and speed. Kinetic energy equals half mass times velocity squared. Velocity, of course, is speed. Suppose a 1,000-kilogram car is travelling at 10 metres per second. That's 36 kilometres per hour, by the way. Go granny. The car's kinetic energy is given by half the mass times the speed in metres per second squared. So that's half times 1,000 times 10 times 10. So that's 50,000 joules or 50 kilojoules. It all makes so much sense. Now, momentum. What is it? Momentum is also about mass and velocity, but its formula is simpler. The momentum of an object is its mass times its velocity. The more mass you have, and the more velocity you have, the more momentum you have. Now, if you lose that momentum quickly, you will feel a large force. Lose momentum more gradually, and you'll feel less force. There's another thing about momentum you need to know. When something explodes, its total momentum before is the same as its total momentum afterwards. And also in collisions and crashes. Let's look in more detail at the cannon. Total momentum before the gun fires is 0. Nothing is moving. After it fires, the cannonball is moving forwards. That's momentum in a forwards direction. The cannonball has small mass and large velocity. Momentum in the backwards direction will cancel this out. The cannon recoils backwards. It has large mass, but small velocity. The two objects, cannon and cannonball, have equal momentum in opposite directions. They cancel out. That keeps the total momentum equal to 0, which is why we get recoil when guns fire. And how jet engines work. How rockets fly and how balloons do their thing. Not that you're ever going to get to see all that at once, unless you go to a NASA-sponsored military-themed jet pilot birthday party. But you never know.